Dear student, myself Rajendra Aaseri, I am assistant professor in computer science department at Government Bangat PG College, Didwana. In the previous lecture, we started a lecture series on database and management system, and we discussed various technique of database design and various tools we have already discussed like ER diagram, entity relationship diagram. In ER diagram, we discussed about specialization concept, generalization and aggregation, how to convert a relationship in high level entity with the help of aggregation concept in the abstraction concept. All these concept already we have done, and then we have discussed about various type of query languages like procedural and non-procedural, and in that we discussed about SQL, that is structured query language, and tuple relational calculus and domain relational calculus. Now, in just previous lecture, we started a new lecture series on the storage media, physical storage media. In that, we discussed about the optical disk, hierarchy of the various storage devices, and cache, magnetic disk, CD, DVD, how to store data in this regarding their capacity and their cost, and volatile and non-volatile memory storage also we have discussed, right? So up to this point we have discussed about the overview of the physical storage media, magnetic disk. Okay, now in this lecture we are starting with the storage hierarchy. So if you look in this storage hierarchy, at the bottom magnetic tabs are there. If you proceed in upper manner, then optical disc, magnetic disk, then in the upper side optical disk, then magnetic disk, then flash memory, main memory and cache memory. So if you are going from bottom to top, then it is the cost of is increasing. I mean, cache is very expensive, right? Lower than that main memory, and magnetic tabs are much cheaper than the cache. Clear? Now second direction, cache is much faster than the main memory. Main memory is much faster than the flash memory. So if you are going from top to bottom, it means speed is reducing. It is for the speed and this is for cost. So left side for cost, left side bottom to top, it means it is for the cost, and from top to bottom it is for the speed. Okay, so from cache to magnetic tabs speed is reducing, and from magnetic tape to cache the cost is increasing, right? So this is about the storage hierarchy. Now in storage hierarchy we are going in detail. So we can classify our storage hierarchy in three categories. First category is primary storage. Primary storage is fastest media, but it is volatile. Volatile means it is temporary. Whenever the power will failure or power is switched off, then automatically the data or content of the primary memory will be lost. In primary memory, there are two type of memories: cache and main memory. Means whatever we are writing inside a cache or the content of cache and main memory will be lost as and when the power will be off. Okay, so they cannot survive the power failure. This is the disadvantage, but advantage is that these are the fastest media storage devices, right? And very costly. Second is secondary storage. In the next level in the hierarchy, so in the next level in the hierarchy, the non volatile means permanent. Okay, the permanent and moderately fast access time. These secondary storage are having less access time, okay, then or sorry, or more access time than the primary storage. That's why it is written here that they are having moderately fast access time, right? These are also called as online storage. Some examples of this secondary storage is flash memory and magnetic disk, right? Now third category is territory storage. These are put at the lowest level in the hierarchy of physical storage media, and these are non-volatile. It means permanent. Whatever data we are putting in territory storage are permanent, and they are having the slow access time, right? They are also called as offline storage. Example: magnetic tape, optical storage, right? Now we are discussing about magnetic hard disk mechanism. So if you see in this diagram, I am taking the marker. Uh, the circular thing is called as what? Track. So there are various tracks. Suppose this is track 1, track 2, track 3, like this. So track T, the inner one is called as what? Track. And in between the vertical line, this is called as spindle. Based on this, this is the base for the all the track. Okay, track will are moving in the circular direction with help of this spindle, right? Now in every track there are various partitions, blocks are there. They are called as sector. So sector is the smallest unit of data storage. In the collection of sector will make a track, and various tracks will make the cylinder. If you see in a cylinder there are various type of tracks involved. So we can say that sector is the smallest unit in the collection of sectors will make the track. Okay, and the collection of tracks will build the cylinder, right? Now if you see in the right side, arm assembly is explained. So these are the arms. Okay, for every track or every track there is a arm, and arm are doing the task of the read and write with help of a head, right? So every arm is associated with a read and write head, right, with the help of arm assembly. Okay. Now next is magnetic disk. Magnetic disks are generally used for the data storage in secondary storage media. Now there are some important point about magnetic disk. First, there is a read and write head. Okay, read and write head are positioned very close to the platter surface. If you see here, so in this every track is having a platter. The surface is called as what? Platter, right? So in case of magnetic disk, these are positioned very close to the platter surfaces, almost touching it, right? Reads or writes magnetically encoded information. So they are either reading or writing what? Magnetically encoded information. Next, surface of platter divided into circular tracks. If you see, this is the platter. Now platter is divided in various type of track, and track is further divided in various sectors, right? So if you see, surface of platter divided into circular track, like over 50,000 to 100,000 tracks per platter on a typical hard disk. In a single hard disk, we can assume about 50,000 to 100,000 approximate tracks are possible on a surface, right? Each track is divided into sector. A sector is the smallest unit of data that can be read or written. Okay, already I explained this with help of this example. If you see, so in this every track there are the smallest part, that is what? Sector, and this is the track. Okay. So platter consists track, various track, and every track consists various sector, right? A sector size typically will be of 512 bytes. Typical sectors per track. In a single track there may be typical sector 500 on inner track and 1000 on the outer track. Okay, so to read or write a sector, so in To read or write a sector, disk arm swing to its position on the head on the right track. In order to read or write, the disk arm, this is the arm assembly, and disk arm need to position on a right track on a right sector so that a particular sector will be read or write. So head position is very important. So in order to read or write a sector, disk arm swing to a position head or on the right track, right? Now platter spins continually, okay, and data is read or written as sector passes under head. So is this platter will spin continuously so that the particular track when comes with the disk arm head, then that particular data will be read or write as the sector passes under the head, right? Next is hard head disk assemblies. Multiple disk platters on a single spindle 1 to 5 usually can be possible. One head per platter and mounted on a common arm. Now cylinder I consists of ith track of all the platter. Suppose there are various cylinders are there. So cylinder I. Suppose cylinder I will consist what? The ith track of all the platters. Okay. Now next is magnetic disk. Now, in earlier generations, discs were generally susceptible to head crashes. Whenever head crashes, then the magnetic disc will be destroyed. Okay, so surface of earlier generation disc had metal oxide which contains would disintegrate on head crash. Okay, they would disintegrate on the head crash and damage all data on the disk. Okay, now current generation disks are less susceptible to such disastrous failure, although individual sectors may get corrupted, right? So next is disk controller. It is also very important unit of magnetic disk. The disk controller is an interface between the computer system and the disk drive hardware. Okay, it is basically an interface between the computer system and the disk drive hardware. It accepts high level command to read or write a sector. It initiates actions such as moving the disk arm to the right track and actually reading or writing the data. It computes and attaches checksum to each sector to verify that data is read back correctly. So checksum is used for checking the errors. Okay, if data is corrupted with very high probability stored, then then the stored checksum won't match recomputed checksum. Okay, if the checksum is not compare we are comparing and checksum is not same, okay, not equal, then we will say there is some error. Okay, data is corrupted. It will ensure successful writing by reading back sector after writing it. So read back mechanism is also present in order to ensure that the writing has been done successfully. It performs remapping of bad sector. Bad sector means which the sectors which are not performing read and write operation as per the requirement. Okay, they are called as what? Bad sector. So in this lecture, we discussed about the storage hierarchy. In storage hierarchy, we have done the comparison between various type of memories like cache is the most expensive and very faster than all the other memories. Then comes the main memory, then flash memory, then magnetic disk, optical disk, and magnetic tape. So storage hierarchy generally classified in three manner: primary storage, secondary storage, and tertiary storage, right? So we discussed in primary cache and main memory, secondary flash memory and magnetic disk, and tertiary all the offline storage like magnetic tape, optical storage, and all the removable disk or removable storage devices. Then we discussed about magnetic hard disk mechanism. In that we are having platter. In a platter there may be various tracks are involved. Every track is containing various sectors. When the disk arm assembly or read or write head is positioned on a particular uh, correct sector, then it will read the corresponding sector data and it will move further. Okay, so in this manner the data will be read from all the sectors and track by track. So read and write head mechanism we discussed. Tracks, how many possible tracks are possible on a platter, sectors. Okay, and in order to read or write a sector part, mechanism is applied. All these we have discussed. Then about magnetic disk, we discussed about disk controller, which is an interface between computer system and the disk drive system. Okay, then in order to check that our data is corrupt or not, there is a mechanism called as checksum. So if our data is corrupt, then with very high probability stored checksum that will not match with the recomputed checksum, right? So that's all from this lecture. In the next lecture some new concept on the storage media. Thank you.